I'm recording this video for the folks at Rocky Mountain Power to illustrate an issue power system in this valve. Today we're going to be doing a couple of different sets of tests. We'll be measuring the line straight out of the wall first, and then we'll be measuring my UPS battery output. The first test will be digital multimeter, followed by volt ohm meter, followed by oscilloscope. You can see here our line output, about 123 volts, 122 volts AC. That is not an issue. That is as we expect. The voltage is fine. It's not a true RMS meter, but for the sake of this test, it doesn't need to be. It just gives us some reference point. So this voltage is good. That's what we expect to see. The next test will be the volt ohm meter, which is a galvanometer. It's an old Simpson. We get him connected up, and the probes that I have for this meter aren't the greatest. They're short. They don't reach into the extension cords openings very well. So you can see it takes me a second to get it connected to the tab in there correctly. But once we do, we'll be able to see that the voltage appears to be fairly stable. Needle doesn't jump around. Needle stays in one spot. Seems pretty good. The next test we're going to do is we're going to look at the waveform coming out of the line with the oscilloscope. Now that is the waveform coming out of the wall for Logan, Utah. Oh, wrong way. Now we can see what is supposed to be a sine wave has a lot of artifacts. Okay, you've got this jiggly bit here. No idea what's causing that. Then you've got this 45 degree phase delayed, what appears to be crossover distortion, but if you look real close, it doesn't just come over and slow down and then go again. That's a spike. Okay, now what that's caused by is an induction load. That is an inductive back EMF spike into the system somewhere. And what this means is that the local power station either does not have sufficient or does not have PFC, power factor control, right? Because what you would do if you saw this, you should have power factor control, which modern active power factor control is going to be a little bit different. But for the sake of this argument, let's assume for a moment we're just using banks of inductors and capacitors on gigantic relays that we switch on and off depending on the sensed load characteristics of the system, right? What you see here means that you don't have enough capacitance. Okay? I have no idea what this is, this artifact here, this near crossing at 0. But you can also see up here, the voltage is coming up, it drops, and then it continues going up again. All right. The next set of tests, again, this is going to be the battery output from my UPS. This is a server-rated, quote-unquote, industrial sort of UPS that has some line conditioning inbuilt. But you can see 121 volts, slightly lower than the line, but not enough that it matters. Back to the volt ohm meter. Set to AC 250. And this cable is coming out of the switched battery output from my UPS. And once the camera focuses, we can see it agrees with the digital multimeter pretty closely. Small differences given by calibration differences. And then, of course, the oscope. Now you can notice the waveform does appear to be a little bit different from the line. And that's that little bit of battery smoothing that you get in there. But it still shows quite bad artifacting. And for the sake of this video, both of these pieces of test equipment share something very important. That is the way that they measure. When talking about both of these pieces of test equipment and how they measure or display is averaging. Right, now Rocky Mountain Power, I called them up and talked to somebody. And they sent a technician over with a little device. And that device, based on its size and its weight, would have been one of these. And after a week or so, they came by and they grabbed it. I get a call from an engineer while I was at work. At the time, I worked at a semi-secured facility, so no phones on site, right? You leave it in a locker and you go to work. So I got a call from an engineer, left a message. I tried to call him back for 3 weeks. Every 2 days, I tried to call him back. Left multiple messages, never got a response. Make of that what you will. I see it at work. I see it in the grocery store. I see it at the bank. I see it in the streetlights outside. And I can tell you, human beings are quite sensitive, whether they can consciously perceive it or not. Human beings are quite sensitive to lighting fluctuations and specific auditory fluctuations. Okay? I suspect the need for the large number of headache clinics is directly driven by this artifact in the power system. This is easily some of the dirtiest power I have ever seen in this country. And it's a problem. And it's causing actual health issues. And it needs to be fixed. That is all I've got for this video. Hopefully an engineer will see this. Because I perceive that as very intense flickering. I see it just constantly, everywhere. And I actually recently saw a Facebook post asking about that. And the response they got from the power company was, we'll send somebody out to look at your house. It's not individual units that are seeing this. This is the power that the entire valley is receiving. And it is wrong.